Hi guys, today we're going to be doing about graphite and graphene, which are both allotropes of carbon. So remembering that an allotrope is where we've got the same substance that arranges differently. So both graphite and graphene are both made only of carbon, but they have different structures, so that means they are allotropes. So by the end of the lesson we're going to describe the structure and bonding in graphite and graphene. We're going to explain the properties of graphite and graphene as well. As always, 5 minutes on the starter. I want you to tell me how many bonds does carbon form and how do you know? What's the electronic configuration of carbon? What kind of structure is diamond? I want you to give 2 uses of diamond and explain why they can be used in those ways, and explain why diamond has a high melting point. So pause the video here, give yourself 5 minutes, have a go at the starter. So, answers. How many bonds does carbon form and how do you know? Well, it's 4 bonds, because it has 4 electrons in its outer shell, and it can use all of those to form a covalent bond. So remember, a covalent bond is a shared pair of electrons. So carbon uses 4 of its electrons, pairs them up with other atoms, and so it feels like it has 8 electrons in its outer shell. Because obviously, if we have 4 pairs of electrons, that's going to be 8 electrons. So the electronic configuration of carbon, there's 2 in the first shell, 4 in the second, so it's 2, 4. What kind of structure is a diamond? It's a giant covalent lattice. 2 uses of diamond, explain why they can be used in those ways. Well, we can use it as jewellery because it's lustrous, and we can use it as cutting tools because it's hard. So we put a little bit of diamond on the tip of drills to help it get through other materials. So why does diamond have a high melting point? Well, it's because each carbon forms 4 strong covalent bonds, meaning that to melt it, you'd have to put in a lot of energy to break the many strong covalent bonds. Okay, so graphite. Look at these images here. Tell me, what are the similarities and what are the differences that you can see? So think, how many bonds does each make? And what shape are they both? So leave a bit of room at the bottom because we're going to add more as we go throughout this lesson. But just write a list of similarities and differences between the structure of diamond and graphite. So how many bonds, what shape are they both? So pause the video here and write some of that stuff down. Okay, so now add to your lists. What are the similarities, what are the differences? But importantly, we're also going to include the properties that each have. Just going to watch a short video that should help us.
This is looking at the difference between diamond, which is this thing here, and graphite, which is this thing here. So diamond is a colourless solid, usually used in rings. It's incredibly hard. It's used in cutting tools. And this is graphite, usually used in pencils. It's also used as a lubricant. So diamond is hard and it does not conduct electricity, whereas graphite is soft and it does conduct electricity. And to understand why something is hard or soft, or why it does or doesn't conduct electricity, we have to look at the way that the atoms are arranged. So in diamond, and this is just one small bit of the whole thing, each carbon atom, because diamond and graphite are both made of pure carbon, is arranged in a tetrahedral shape, and each carbon has 4 strong covalent bonds on it. 1, 2, 3. These ones here will have other bonds, but you just can't show them because this whole thing is just a snapshot of a small piece of diamond. Graphite, however, is arranged in layers. So there's a layer that looks like this, a layer like that, and a layer like that. And the fact that it's layers gives it the properties that it's soft and that it conducts electricity. So the reason why diamond is hard is because all the atoms are held together by strong covalent bonds.
So we covered all of that last lesson, so we should be pros on why diamond is hard.
Remember, a covalent bond is a shared pair of electrons. So if you wanted to snap a piece of diamond or break it off, you would have to break one of these bonds here, and these bonds are very strong. So because these bonds are very strong, it's hard to break the structure down, so diamond is hard. This is different from graphite. So graphite is soft, and the reason why graphite is soft is because each carbon has a maximum of 3 bonds. 1, 2, 3. 1, 2, 3. 1, 2, 3. And because it's got 3 bonds, there are weak forces between the layers. So this is one layer, this is another layer, this is another layer. And because there are weak forces between the bonds, it's easy for the layers to move and slide over each other. And because the layers can slide over each other, it makes graphite soft. So graphite does conduct electricity, but diamond doesn't. So electricity is just the movement of charge, and the charge can be either electrons, like in a metal, or it can be movement of ions. Remember, an ion is a charged molecule or atom. For example, sodium and chloride in salt water. Go back one second. So graphite conducts electricity because there are delocalized electrons between the layers, and these delocalized electrons can move. So if you imagine this is some delocalized electrons, this is some delocalized electrons, these can move. So the delocalized electrons between the layers can move. And remember, we said that electricity is the movement of charge, and it can be the movement of electrons or ions. And because in graphite there are delocalized electrons, and these electrons can move, graphite conducts electricity. That's different to diamond. So diamond is made of atoms. All the atoms are held in place by strong covalent bonds. There aren't any free electrons because all the electrons are tied up in bonds, and there aren't any ions. So graphite conducts electricity because there are free delocalized electrons, but diamond does not conduct electricity because diamond has got no free electrons and no free ions.
Okay, fantastic. So hopefully we've now got our lists of the similarities and differences, including the properties of each. So let's go through some answers. Feel free to watch that video as many times as you need to get down all the properties. So diamond is hard, whereas graphite is soft. That's a difference. Another difference is that diamond, each atom forms 4 strong covalent bonds to the carbons around it, whereas in graphite, each atom only forms 3 strong covalent bonds to the carbons around it. Another difference, diamond cannot conduct electricity because there's no free electrons, whereas graphite can conduct electricity as there's 1 free electron per carbon, which is able to move. Diamond does not have any layers, whereas graphite does have layers which can easily slide over each other because there's only weak forces holding them together. And this last bit here is what makes diamond hard, the fact that it doesn't have layers, and graphite soft because it has layers. The only similarity between diamond and graphite is that they're both made out of carbon. Okay, so let's look at that in a bit more detail. Why doesn't diamond conduct electricity but graphite does? So graphite only forms 3 bonds. If we look at these GIFs at the bottom, you can see that every single carbon is just forming 3 bonds. So because it's only forming 3 bonds, it forms these nice neat layers which you can see when it turns on its side, like now. So if it's only forming 3 out of a potential 4 bonds, it's got 1 free electron that can whiz around, and that's conducting electricity. Whereas diamond forms 4 bonds and it does not form any layers. So there are no free electrons in diamond structure. Okay, so as we said, graphite forms layers. So these layers are stacked on top of each other, and there's very weak forces between them. So those weak forces between the layers can easily be broken because they're very weak, and these layers can slide over each other, which makes it soft. And as we said, it forms 3 bonds, so there's a free electron, so it will conduct electricity. Okay, some questions for you. So give yourself about 5 minutes, pause the video here, we'll go through some answers in a sec. Okay, so answers. How many single bonds in diamond? 4. How many in graphite? 3. So use the answer to the question to explain why diamond is hard and graphite is soft. Diamond is hard because each carbon forms 4 strong covalent bonds which take a lot of energy to overcome. Graphite's soft because each carbon forms 3 covalent bonds, but importantly they form layers. So when we are able to, well, for example, with your pencil when you're writing, what that is the graphite layers coming away. The actual covalent bonds do not break. The covalent bonds are far too strong for it to break. What breaks is the weak intermolecular forces between the layers. Okay, so as it says here, these layers only have weak intermolecular forces in between, so they're easy to break, so they're able to slide over each other. So the extension question, use the answers above to explain why graphite conducts electricity and diamond does not. So diamond cannot conduct electricity as there's no free electrons in its structure. Whereas graphite, it only forms 3 bonds, which leaves 1 electron free to flow throughout the structure, so it is able to conduct electricity. Okay, moving on to graphene. So what do we think? Is this material possible? It's 200 times stronger than steel. It conducts electricity. It's transparent. It can be described as a 2D material because it's only 1 atom thick. It's one of the thinnest materials that we've ever made, and it promises to transform everything from smartphones, computers, cars, buildings, satellites, and even clothes. So it turns out, yes, this is possible, and it is a material called graphene. So what graphene is, it's a single layer of graphite. So, knowing what we know about graphite, see if you can draw it and predict its properties and explain your choices. So, another 5 minutes, pause the video here, go through some answers in a sec. So it's definitely a challenge, but it's well worth giving it a go. Okay, so it looks like this. It's just a single layer of graphite. That's all it is. So what would the properties of this be? Well, it will conduct electricity, just like graphite, because each carbon is only forming 3 bonds, so there's a spare electron. So this is why we can use it in computers and smartphones, because it can conduct electricity. Now actually on the screen of smartphones, there is sometimes a sheet of graphene, and that's useful because it conducts electricity, so when you touch it, it's conducting the electricity, sending an impulse, and that's how touch screens can work. Okay, what other properties will it have? It'll be hard and have a high melting point, as all of these bonds are strong covalent bonds, so it will have a very high melting point and be hard. Hence why you can use it in buildings, stuff like that. So as we've said, the structure of graphene is it's a single layer of graphite. So it arranges in a flat sheet where every carbon is forming 3 bonds, which means that there's that 1 extra electron whizzing about, meaning that it can conduct electricity. So what can we use it for? Well, we've got a little website here. The applications. So it's very, very strong, which means that we can use it in aerospace, building materials, mobile devices, and lots of other applications. No, we do not want to sign up to the Graphene newsletter. It's also very lightweight. So because it's so strong, we can use less of it, so we get the same strength for less weight. Okay, it also conducts electricity fantastically. It's one of the world's most conductive materials to heat. Oh, sorry, to heat, not electricity. So it can be used as what we call a heat sink. So it takes heat away from areas where it shouldn't be. So imagine in a computer, I'm sure some of you have had it, where your computer gets really, really hot on your lap. Obviously, we don't want the heat to be where the components are, because it can cause damage to them. So you have a heat sink which takes the heat away from the hot components and passes it out. So for example, passes it through to the fan or something like that. Energy storage. So it's a dead thin material, and it's got a very high surface area to volume ratio. So there's potential to use it as for storage in batteries and supercapacitors and stuff like that. And loads more. There's so much more to graphene. So just one material and all these uses. Okay, plenary. What I'd like you to do, spend about 5 or 10 minutes. I'd like you to, obviously you're not going to work in each day, but you'll be doing this individually at home. You're going to imagine life 10 years from now. Using the properties and uses that we've looked at so far, how do you think graphene could change your life? I want you to predict different ways graphene could change your life. Now I'd like you to design a product that's made from one of the allotropes that we've learnt about today. So either graphite or graphene. I suppose you could use diamond as well. And design a product from one of those allotropes. And I want you to include how it could be useful. So pause the video here, give yourself 5 or 10 minutes to do that. Okay, fantastic. Last thing is your homework. Following on from what you've just done, I want you to create an advert for your product. It must be at least one side of A4, but some people may choose to do more. I want you to include a drawing with labels, a description of why the material is suitable for the product. So say why you've chosen the product and why the material helps it be good at its job. And I want you to be creative. Once you're done with this, I'd like you to submit it to show my homework so I can mark it. And that's all for today, guys. You've done a fantastic job. See you next time.